Okay, so far we have solved the first two challenges of Stack Overflow successfully. Now the third challenge, which is like Stack 2 in this particular case, and this looks like a very easy challenge, somewhat very similar to Stack 0 and Stack 1. So I would like you guys to to solve this challenge by yourself. Now okay, so yeah, the solving is solving of challenges is fine and everything looks good on the first place. Now let me just give you guys a bit of hint regarding the challenge. So in this particular challenge, again, the buffer size is still 64. The environment, so in this particular case, you just basically need to to set an environment with the name greeny, right? And then this environment is basically copied into the buffer. So you have to make an environment such a way that it overrides the buffer, and then not to forget about this particular if case where the address is already mentioned. And also, while writing this particular address, you also have to take care and understand about the little endian concept which we explained, which we kind of discussed in the previous video. So yeah, you do have to undertake those things, and then you finally form your exploit around it, and then you are done with that. Okay, so I just don't want to go and solve this challenge for you guys. I want you guys to solve the challenge by yourself. If you somehow manage, if you guys are facing any problem while solving the challenge, do let me know. I'll make a quick video on that, or maybe I can just show you, share the example, or write, give you guys a hint, more hint, or if you guys want a solution, I can even provide you guys with a solution. But I really want you guys to solve this stack 2 by yourself. Now coming back to stack 3, this looks like a bit interesting because there's a new command that I'm going to introduce you, and those things are gonna be required by you in the coming challenges. Okay, and some more concept as well. So this in this particular program, you basically have to execute this win function. Now if you see the main function, there is no calling of win, right? But then you see there's a pointer fp, right? So you basically, if you somehow manage to place the address of win function on the pointer fp, then you will definitely be able to to move this, to call this win function over here, because this fp is basically being called here, right? So yeah, that's more or less the whole idea. So but the question is, how do we find the address of win? Everything looks fine, like the buffer size is 64. So yeah, everything is fine. We have the buffer as 64. We know we can override the buffer, but how do we get this address of win, right? So now let's go back and try to solve this challenge. Now in order to get the address of win, what we are going to do is we will just use the obj dump command. So basically obj dump is obj dump minus states. That is what we are trying to do, is we are trying to disassemble the binary. Okay, and so you'll see once we disassemble the binary, you can see a lot of that when a program runs, there are a lot of libraries that is being created as well after compiling, right, to make it a standalone. So all these libraries, their addresses are being mentioned, and you can see there's a main function as well. So the main function basically starts on the address 08048438. Now you can see our win function as well, and the address of win function is 08048424, right? So this is the address of win function. So we basically got the address. Now there's one more important concept. Well, we're not going to need that concept in this particular video, but for the next video we are definitely going to need it, and that is return. Okay, so basically return is the, what do I say, like once the program ends, okay, it goes to the return, whatever the address is basically stored here, okay, it goes to the address. So when you're running a program from your cell, right, after the program is, the output, you get the output, the cell actually comes back to that particular place, right, like, the beginning side. Okay, so for example, when I ran this obj dump command, finally after giving me the output, it ran to this particular, to this particular case, right, into this cell, I would say, like, shell kernel, whatever you say, shell, right. Now the thing is, in this particular case, where we were actually missing, this thing is return address, is the return address was basically storing this address where it is supposed to come, okay, even before running the program. Okay, now it stored the address, it ran the program, it knew that, okay, once the program end, I have to point the, point the pointer to over here and return back to this particular address. If it didn't knew where to return after the execution of program, then the program would stall, then the entire system would basically stall there. So that is why the return address is very important. In the subsequent challenges, we will try to override the return address so that when the program ends, instead of ending the program, we'll try to move that particular program to a different address where we really want it to move. Okay, so we'll talk about the return address there, and then again we'll also talk about the NOP. Now NOP is a very exciting thing, really very exciting thing to know, and it's pretty much easy as well. Okay, uh, but then again, yeah, I mean, we'll talk about all those things, and we'll also see the shellcode. But anyway, coming back to our own program, so now we have this, the address, when the address of the function when, which we basically have to again use the little ending format. So the whole idea would be to, to write it backward. Now let's try to sense it, because it does not take any argument, so I really don't have to, to write about the argument. Okay, so 64, then what we have to do is we'll just have to write the address. So let me just go back and look at the address. 2484 sorry, 04, I guess 08. Let me just verify it once. 24840408. Yes, writing in the backward 2 bytes at the same time. Okay, and then we do a pipe and ran this stack 3. Okay, so, well, we made some mistake over here. Okay, so somehow we made a mistake by either by, like, typing or something. Let me just quickly go back and try to see. If you see here what it says, calling function pointer, jumping to the location 04 0048 8424. Okay, so basically it is not the address that we really want, right? Somewhere it is making a mistake by, so it is taking 24 is fine, 84 is fine, 04 is fine. You see, this is the problem. We are not able to provide the right address. Let me just try to run the program once again. It should have been, okay, it's the same. Now let us just go and try to find out what might be the problem here. So I'm not sure if you guys found out the problem, but I was making a stupid problem, and these kind of problem are very much common while you are, too much into the zone of solving the challenge. Okay, the problem which I was making was, if you see, you know, in a particular order, like, if you see it closely enough, you see that I have been missing X. Okay, forgetting to mention about the hexadecimal value, right? And that is the entire problem is where. So I just made this, stupid problem so that you guys even understand that where it is coming from. Okay, so the next time when when you face this kind of problem, you don't mess up with the entire thing. Okay, so I hope like we don't have any more problem while solving it. Okay, so it looks like yeah, fine. So we kind of like got our stack 3 as well. Okay, yeah, so it looks like pretty much everything has been solved over there, right? We got the flag code flow successfully. Okay, so let's go and try to solve one more challenge on which has a concept of return address and the NOP, and maybe even the shell code as well. We'll see if we can find out one more challenge, uh, and then we'll move on to heap overflow. So thank you guys.